Assalamu alaikum. Hello everyone. Today I'm going to discuss with you some problems from Conics. Before going to problems, here I'm sharing with you some basics from Conics. What is Conics actually? Here we see conic section or conics are the curves obtained by intersecting a plane with a double napped cone. The word conic is actually come from cone. Okay, depending on the angle and position of the intersection, four types of conic section can be formed. If we notice the picture here, you see there is a cone here. In a cone we know this is a circle and this is axis and this is the generator. If a plane intersect this cone like this, then we get a circle, and if the plane intersect this cone like this, we get a parabola. Similarly, here we get a ellipse and here we get a hyperbola. This is the definition and visualization of different conics. Now next here in the next different types of conics, the definitions are first of all is a circle. Here a set of so what is the circle? A set of all points in a plane that are equidistant from a fixed point called the center. Here HK is the center and R is the radius. Second, ellipse, the set of all points for which the sum of the distances to two fixed point is constant. Here this is the equation of a ellipse where HK is the center, A is the semi-major axis and B is the semi-minor axis. Okay, next is parabola, the set of all points equidistant from a fixed point and a fixed line directrix. For a vertical parabola, equation is y minus k is equal to a times x minus h whole square, where hk is the vertex. And hyperbola, the set of all points where the difference of the distances to two fixed points is constant. Here is the equation of a hyperbola. For horizontal hyperbola, equation is this is the equation for horizontal hyperbola, and this is equation for vertical hyperbola. Then there is an important definition: eccentricity. Eccentricity actually measure of how stressed or flattened a conic section is. For circles, E will be 0. Ellipses is greater than 0, less than 1. Parabola is equal to 1, and hyperbola is greater than 1. Now I'm going to show you some problems from the conics. Here is our first problem. This is the stem we are given. First we have to find the equation of the asymptotes of the hyperbola, then find the equation of the directrix from stem A, stem 1, and the figure of stem 2 is parabola and vertex A. Then we have to determine the length of CB. Part A, first of all, here we are given this equation. We can we will transform it to in hyperbola form, where A is equal to 3 and B is equal to 2. Here and transverse axis is along x-axis and conjugate axis is along y-axis. So the equation of the asymptotes is y is equal to plus minus b by ax, is that implies y is equal to plus minus 2 by 3x, which implies 3y is equal to plus minus twice x. Okay, now in part B, from stem 1 we have this equation. We have to find the in part B we have to find the equation of the directrix from stem 1. Okay, so this is the equation. First we have to transform it into standard form, where we get this equation. Okay, Then then we get the eccentricity here 3 by 5. So equation of directrix is equal to x equal to plus minus a by e, from where we get two equation 3x minus 28 is equal to 0 and 3x plus 22 is equal to 0. These are the equations of directrices. Okay, now part C. In part C, our question was the figure of stem to is parabola and vertex A. Then we have to determine the length of CB. Here vertex of the parabola is 0, 4 and x is parallel to y axis. Okay, so equation of such parabola is x minus 0 whole square is equal to minus 4a times y minus 4. So it passes through this point. Okay, so here we get the value of a is equal to 9 by 4. Equation of the parabola is x square is equal to minus 4 times 9 by 4 times y minus 4. Here we get the equation 1. So if 3 alpha be any point on the parabola, so from 1 we get the value of alpha is equal to 3. So coordinate of the point B is 3, 3. Then we get the coordinates of C, which is 3, 0. So length of CB is root over 3 minus 3 whole square plus 3 minus 0 whole square is equal to 3 units. Okay, so next, in scenario 1 we have the equation of the parabola. Scenario 2, this is the equation. First we have to find the eccentricity of the ellipse. Then S is the focus and SP is equal to 6 unit in the scenario 1. Then we have to find the coordinates of the point P. Then we have to find the equation and length of the lattice rectum of the conic given in the scenario 2. Here is the equation. We can transform into this and then where a is equal to 1 by 2, b is equal to 1 by root 5 and a greater than b. Then eccentricity is root over a square minus b square by a square. Then 1 by root 5 is the eccentricity. Then in part B, from scenario 1, equation of the parabola is y square equal to 16x. Here y square we can write y square equal to 4 times x. A is equal to 4 is equal to a. So focus a is equal to 4, 0. And let p alpha beta be any point on the parabola. Focus 4, 0 and vertex a 0, 0. And PM and PN are two perpendiculars respectively. Okay, two perpendiculars respectively on the directrix and axis of the parabola. By the definition of parabola, PS is equal to PM. Since 6 equal to AZN is equal to ZA plus AN, so 6 equal to AS plus AN. Okay, so 6 equal to 4 plus alpha, alpha is equal to 2. This alpha beta is located on equation 1, so beta square equal to 16 alpha. That's why beta is equal to plus minus 4 root 2. Okay, since the point P lies in the first quadrant, so beta is equal to 4 root 2 and required coordinates of the point is 2, 4 root 2. Here actually first we find the value of a, right, as, then the focus, that's from there we get the focus s, and ps equal to, since ps equal to pm, we can write 6 equal to zn and za plus an. Then we get as plus an. Here we get the value of alpha, which is the abscissa of P. Okay, so P is located on the equation 1 on the parabola. Okay, P is on this parabola. So if we put the value, this value will satisfy this equation. Okay, this coordinate. So from there we get the value of beta only. Okay, if we beta and we also get the alpha. Since it is in the first quadrant, that's why we only take the positive value. Thus we get the required coordinates of the point. Okay, part C, this is the equation. From here we get a standard form, and which is identical to this equation. Here a is equal to 2 root 3, b is equal to 2, a greater than b. So this is the eccentricity 2 by root 3. Okay, 2 by root 3. Then equation of length of lattice rectum is x equal to plus minus ae. From there we get x equal to 6 and minus 2. Equation of the lattice rectum are x minus 6 is equal to 0, x plus 2 is equal to 0. So length of the lattice rectum is 2b square by a, which is 4 by root 3 units. That's all for today. I hope this problem will help you to understand the topic conics easily. Please subscribe my YouTube channel, and let me know which problems you are facing with, or facing difficulty. I will try to bring those problems in my next video, and support me please. Thank you everyone. Assalamu alaikum.